So here we are with some of the greatest people on the DeepMind team, potentially. So before we get started, would you guys like to say anything else about yourselves, or like give a brief intro as well?
Sure. So I've been like a deep learning for research for a while. I started internship at Google Brain 2015, and since then kind of worked pretty much at Google Brain, and then OpenAI, and back at kind of Google DeepMind. Before the step-by-step kind of paper, I wrote, gamma softmax, this kind of very technical stuff, and improving the sample efficiency in our algorithm. But since about 4 years ago, to be precise, I felt everything's ready. We can create the digital AGI and the physical AGI. So since then, I've been pretty much kind of focused on Frontier Lab and doing whatever is necessary to make the kind of best models.
I'm Jay. I've always been more of a visual person. So when the generative AI boom started, I guess back in maybe early 2010s, I've always just enjoyed working on image and multimodal generation. So that has continued. Worked on Imagine Video during my grad school, and that line of work ultimately led me to working on Banana and Gemini Omni now. And I do think right now we are kind of reaching the inflection point where these multimodal generation models are not just generating pretty images or videos, but they're actually generating real content with intelligence in it. So that's the part that I'm most excited about.
I'm not certain I'm excited about my age, but I think I programmed some basic backpropagation perceptron on an Apple II in the early 80s. And that was the moment where people said, it doesn't go anywhere, it's useless. Because nobody considered the fact that you may use more than one layer. I mean, that only stopped the whole industry for 10 years. But over the years, I kept a good eye on what was happening in ML in general and neural network. But it's only a year and a half ago that I moved from Google X to DeepMind. And this has been an incredible ride. I mean, first of all, because at first you're quite incompetent. So, you need to get over it. You need to drink from the fire hose. But at the same time, first, I think I have one of the best jobs in the world. So I feel very lucky. It is also an incredibly exciting time. I mean, the world is changing day by day. And, being inside DeepMind and seeing what's happening from a research standpoint and the progress which are coming, it's pretty mind-boggling to see or to not be able to predict anything past, 6 months. I know people were asking Sergey what Google will be in 20 years. It's like, end of the year is a good target. So because things are moving so fast. Super incredible time. Incredibly blessed to be here.
Amazing. Yeah, and we're very blessed to have you all here. Thanks. So I'm very curious, Benoit, were you also in research or academia before entering DeepMind and I guess Google and other companies?
Oh, it's a long story. I actually started by writing video games for Apple II and Commodore 64. That's why I came to the US for the first time. But over the years, I spent 10 years on operating system design. That was an operating system named BOS over my trajectory. If you do not allow people to fail, they will not try hard enough. It's like a Formula One driver that never crashes. It's like, come on, you're not trying hard enough here. I think it's the same thing for innovation. So I think creating that culture of respect, openness, allowing people to express ideas that might be a little bit outside of their domain of expertise, all of those things do magic to create innovation. Now, the other part you mentioned is how do you get innovation to go into products? And that's another great subject. One thing I've learned over the years is that if you're a research organization and you join a company, the first thing you want to get along with is sales. Because if you can convince the sales team that what you may achieve will be important, sales tends to create the music in companies. So get sales to be very excited, maybe get them to even speak a little bit of what's coming up. That's a great lock for your research work. The other aspect is clarity of story. Do not expect people to put a lot of effort understanding the brilliance of what you're developing. So having a story that other people can adopt, or even better, make their own, is probably one of the most powerful things you can do. But get something which is very clear on the purpose, on the impact, on the cost. And if you achieve those things and get sales excited, you're on a roll.
Amazing answers all around. When I hear you talking about how to turn innovation almost into an engineering practice, and it's basically what you do is like, and because you all have engineer backgrounds, but innovation is your business, it really makes me excited to think about AI coding, which is in a way automating the process of software engineering. And then it feels to me like almost one step after that, or maybe not too far, is like almost like AI scientist, or like an AI for discovery and innovation that can actually optimize this process and speed it up. I think internally at Google, coding and AI for science and discovery are some major areas. Do you all have any thoughts on that, or would you like to discuss it?
Yeah, definitely the kind of coding is the most exciting area right now. 4 years ago, I also wrote the large language model can self-improve. And there, the example the kind of pick was a math model, but essentially kind of math and coding is, quite verifiable. I think what's kind of also quite unique about the program is that it can basically, you basically kind of see through the process like a lot more, and then you can basically design, because math you like a lot of time you kind of do by hands, but program is like you kind of write your sort of thinking process and it's kind of over here. So in a way, kind of coding can do like much longer sort of like reasoning kind of like stuff, general knowledge kind of embedded. So I'm very excited about the coding, and yeah, just recursively like when you can really kind of tie this sort of verifiable reward kind of learning with this sort of very targeted kind of like self-improvement. So the key is to really get a frontier use case. Right now, we kind of moved from offline supervised learning to online supervised learning, which is kind of what's required to get to 100%. But in there, what's the reason? Like to get to like 95% model, you need to have 94% product. To have this kind of use cases is like 94%. To be able to kind of get to 95%. So we care a lot about the final last miles, and many people do are kind of working hard to reach there.
That's great to hear. We have time for one more question before we're moving on to our next panel.
I'd also add that, kind of going back to Sergey's point about having this self-improvement perspective versus world modeling. I guess working on Gemini Omni, I do follow the world modeling view a little bit, and you can imagine that if you have a good world model, you can trivially capture the problem that you want to solve. So for example, you can ask the model to generate somebody solving an NP-complete problem, or like coming up with a math proof for a very difficult problem. And obviously current models cannot do that yet. But what this shows is that the intelligence of your world model is actually tied to its world knowledge and understanding and reasoning capabilities itself. So I think working on that will basically give us a simulation in which we can accelerate a lot of tasks, in particular science. So if our world models were strong enough to be able to actually simulate physics well, then we could actually replace a lot of the test bed for natural science to be run with it. And I think that's kind of a direction that I'm very interested in.
And first of all, I must say I'm totally addicted to vibe coding. I've got continuously 20 instances of Gemini working on some problems which I think are interesting. And it's not just writing the code, it is trying to push them to think about algorithmics and make progress. But if I look at code and I look at the horizon of things that we need to solve, there used to be a clear terminology for that. There was code writing, there was software engineering, there was software architecture, there were UI design. I mean, all of those things were well understood as different layers of the process. And when you look at what we're doing with models today, we're going back through those steps. I think that code writing is done. I mean, I cannot think in the last few months a case where Gemini wrote a code fragment and I can do that better. So, no, man, that's over and out. Software engineering is more interesting because it is managing complexity. It is, you have a code base of 15 million lines of code and you need to implement the features. Very different type of skill. We're still making clear progress on that. Architecture, that's even harder because it starts to touch to many aspects of what will the software actually do, or what are the physical limitations of the hardware you're going to run on. So I think there's still a very clear frontier there. UI, strangely enough, is working pretty well. I mean, world model and nano banana and other techniques taught us a lot on what constitutes a good UI. So I think that one is, with the basic hygiene of code writing, are the two things which are moving very fast. But I think that there are quite a few other layers that still needs to be addressed.
Wonderful. Vibe coding, I also love to do it, although I try to say agentic engineering if I can. So time for one more question. I'll make it good. All right. So for coding, it's very interesting because it's like semi-verifiable code. I mean, it has to like compile, for example. I think it's a wonderful place to test reasoning, and that's what we've been doing. And it seems like you guys are probably state of the art. I mean, I always thought Google has the best coders historically, and I feel like they probably still do. So they should have the best coding model. It's like not a stretch. But I'm very curious, how do you improve the thinking for the coding models? And in fact, is it possible to go beyond symbolic thinking?
Yeah, so in fact, like I feel most of the world's information is kind of contained not just on symbols, but also like kind of space and time information, and then video models are kind of good model to like express it. So kind of half a year ago, we kind of wrote a paper called Video Models for Zero-Shot Reasoners. So that could also be a kind of one axis where we can kind of like access like much richer information that we kind of have in the data. And then.
Yeah, and I think just as humans, we do not think solely in textual terms. So I think it's like we have made a lot of improvement in the textual thinking ability, and the industry as a whole has done that. And there's still more to go, but I think on the visual front, we're still at a more nascent stage, and I think incorporating that into a model's thinking process is, seems pretty promising to me.
First, I want to second that. I think that the thinking process is going to still evolve a lot. I mean, many of you write code. Code is not thinking in English. It might be visual, it can be dynamic, so there is a much richer vocabulary than what we typically use for something like chain of thought. So I think that a lot of the progress, and I'll be careful what I talk about, but chain of thought was great. I think we can do much, much better. I think that thinking is just at the beginning, and code, as you mentioned, is an incredible benchmark that validates if the thinking is correct or not. It's pretty incredible when you look at those models. They are trained mostly on GitHub data. I mean, the majority of GitHub data is garbage. I contributed a fair amount of it. It's amazing it works at all. So I think that moving forward, for instance, synthetic training case become really important because they allows us to go past the human level of coding capability. One example, I mean, a very simple way to do synthetic improvement on code is you take a code fragment, you tell the model to explain that code fragment in English. And then you take that English fragment and you give it back to the model again and say, write the code. And then you compare the functionality of the two. These are the type of things that forces the model to not just write the code, but understand the code. So I think that's a big trend we're going to see.
Super fascinating. I wish I had more time to ask more questions, but alas. Thank you so much. This was super cool. And yeah, welcome to AGI House. Thank you.